Welcome to a video for Math 2 for section 10.2, which is on more multiplying properties of exponents. So to begin with, we have our first property, which is power of a power. So this is the case where we have a power such as x to the nth power being taken to another power. So there will be parentheses around it, and then there will be another power. So let's just explore this for a second and think about what would happen. Let's say you have 2 cubed to the 4th power. Well, taking something to the 4th power means to multiply it times itself 4 times. So we are going to take this 2 to the 3rd and multiply it times itself 4 times. So that would be 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd, 4 times. So then we know from a previous lesson that when you are multiplying things of the same powers of the same base, you would add these exponents. So if we add 3 plus 3 plus 3 plus 3, that is the same as 3 times 4, because instead of writing this, we know that repeated addition is the same as multiplication. So that would give us 2 to the 12th power. So in general, the rule is we multiply the exponents. So n times m. Okay, so whatever exponent you have here, you would multiply times whatever exponent you have here. So you get the new exponent is the product. So let's take a look at some examples. 6 to the 3rd to the 4th would be 6 to the 3 times 4, which is 6 to the 12th. We don't need to go any further because the instructions just say rewrite the expression using the base only once. So that's it. For example 2, we are going to multiply 1/3, which is this exponent, times 15. So we do have to remember how we multiply fractions, because these are both, well, 1/3 is a fraction. When we multiply fractions, we should check for cross-canceling, which in this case we do have. 3 goes into 15 5 times. So then if we multiply across, we just get 5. So the answer to this is x to the 5th. All right, with our last one, we have negative 32 to the 2/3 power being taken to the 6/5 power. So we have a power of a power. We are going to take these two fractions and multiply them. The negative 32 isn't going to change right now. So let's write them as a product. And we should check to see if anything cancels, cross cancels. And we do. We have 3 goes into 6 twice, so this is going to be at 1. If we multiply across, that's going to be a 4 over 5, so that's our new exponent. So the complete answer is negative 32 to the 4/5 power. Keep in mind though, we talked about how a rational exponent, the denominator, is a root. So we can rewrite this as the 5th root of negative 32. Now the 4, that means we're taking it to the 4th power. So the 5th root of negative 32 is asking what number, so what number to the 5th power gives you negative 32? Well, yes, it can be a negative number, because if you have 5 negative numbers, your result will be negative. So I do know it's a negative number. I don't need parentheses there. In fact, the answer is, if you play around with your calculator a little bit and you start multiplying something times itself or to 5 times or taking it to the 5th power, you'll eventually get that it is 2. Okay, so that, actually I didn't need parentheses here because this part is the -2. But now we can take it to the 4th power. Remember, the 4th power comes from the numerator. All right, -2 to the 4th power would be -2 times -2 times -2 times -2. When you have an even number of negatives multiplying, the negatives will all cancel. So these two will cancel, and then these two negatives will cancel. So now I'm really just multiplying 2 to the 4th power, which is 16. So this completely simplifies to be 16. All right, let's take a look at another property that has to do with multiplying, and that is raising a product to a power. This is the property where you are going to have some parentheses and you're going to have a product inside. Something times something. Now this could be 2 things or 3 things or any number of things. And they're being taken to a power. You know what, instead, let's say that power is the nth power. Okay. What this is saying is that this is equivalent to a to the nth power times b to the nth power. So essentially, a will have that exponent of n, and so will the b. Now, this idea works for a product, things that are multiplying. But it is very important to understand that this does not work with addition. So if I were to do this, this is fundamentally wrong. And this is a mistake that math teachers, including myself, see many, many times. Okay, so it only works if there is a product. It also works with quotients, which are division, but division is a form of multiplication, so it makes sense. But it does not work with addition, and it does not work with subtraction either. Okay, so adding and subtracting, this does not work. Just keep that in mind. All right, so now let's give it a try. So here we have 2 times x cubed to the 5th power. So using this idea, we're going to take 2 to the 5th power, and we are going to take x cubed to the 5th power. All right, so it's going to be 2 to the 5th power times x cubed to the 5th power. 2 to the 5th power, if you use your calculator, will be 32. X cubed to the 5th power, well, that is another rule. That's the rule we just learned right here. This is where you have a power to a power, so we are going to multiply. So we are going to multiply the 3 and the 5 to get 15. So final answer is 32 times x to the 15th power. Okay, let's give number 2 a try. We've got more things going on here. We have an 8. We have a y to the -1. And let's get a different color. How about orange? And a z to the 4th. All being taken to the -2 power. So we're going to start by writing out 8 to the -2 power times y to the -1st to the -2 power times z to the 4th to the -2 power. And then let's go ahead and figure out what all these things are. Let's start with the y and the z, because those are actually a little easier. We have exponents. Those are going to multiply. These are also going to multiply because it's a power to a power. All right, so that's going to be y to the positive 2, because a negative times a negative is a positive. Then we're going to have z to the negative 8th. I'm going to go ahead and leave this as 8 to the negative 2 right now. All right, we talked about how when you have negative exponents, like this one and this one, it means that you need to move them to the other part of the fraction. So right now, these are in the numerators. I know you don't see a denominator, but imagine your denominator is all 1. So these negative exponents are going to move to the denominator, and when they do, they're going to become positive exponents. Now, the y squared is this is a positive exponent, so he's going to stay right where he is. He's happy. The 8 to the negative 2 is going to become an 8 to the positive 2 in the denominator, and the z to the negative 8 is going to become a z to the positive 8. Now we can square the 8. So final answer is y squared over 64 z to the 8th power. Okay, one more of this set of examples. We have 25 times a to the 2/3 all being taken to the 1/2 power. So once again, the 25 is going to be taken to the 1/2 power, and the a to the 2/3 power is going to be taken to the 1/2 power. So we start there. So 25 to the 1/2 power times a to the 2/3 to the 1/2 power. Let's apply what we know to figure these out. 25 to the 1/2 power is the same as the square root of 25, which is 5. A to the 2/3 to the 1/2 power, this is a power to a power rule, so these are going to multiply. When I do the fractions, sometimes I like to do the multiplying of the fractions on the side. So that's an option you can do. I'm just going to do this thing on the side. So 2/3 times 1/2. The 2's will cancel, and so I get 1/3. So the answer is 5 times a to the 1/3 power. Let's apply what we know to scientific notation. So if we're taking the scientific notation of a power, so let's say we have something in scientific notation. So a times 10 to the nth power, and we're taking it to the mth power. Well, this is a product, and so you are going to take the a to the mth power, and then you're going to have it times 10 to the, and then these two exponents will multiply. So n times m. Let's give an example a try. Here we have 3 times 10 to the 4th, all being taken to the 2nd power. So we are going to start by doing 3 to the 2nd power. So the 3 is like the a here. And then the m is the 2. So I'm taking the a to the mth power. That's the first part. All right, times 10. And then we have our n and our m. And those are going to multiply. So our n here is the 4. So 4 times 2 is what's going to go here. So let's clean this up. 3 squared is 9. and then it's going to be 10 to the 8th power. Because 9 is only one digit, and my decimal would be here because it's a whole number, I don't have to change my scientific notation. It's good. All right, last example. Example 2. The expression 1/2 m times v squared gives the kinetic energy in joules of an object with a mass of m kilograms traveling at a speed of v meters per second. What is the kinetic energy of an aircraft with a mass of 2.5 times 10 to the 5th kilograms, traveling at a speed of 3 times 10 to the second meters per second? So in a word problem here, and they give you a formula, we need to identify what they gave us. So remember that m they tell us is the mass in kilograms. Okay, we have an aircraft with a mass of 2.5 times 10 to the 5th kilograms. So that is our m. So m equals that number. Then we have v, which is velocity. So the velocity that they gave us is, velocity is in other words a speed. Well, they didn't say the word velocity, but that's what the v stands for. It's a speed of v meters per second, and so that is this number right here. So v equals 3 times 10 squared. So we're going to plug it into this formula. So 1/2 times m times v squared. So m was this number, so that's going to go here. And v is this number, which is going to go here. So 2.5 times 10 to the 5th, and then 3 times 10 squared. And this is all being squared. So with any number, you're going to follow the order of operations. So 3 times 10 squared squared. We are going to square the 3 and then square the 10 squared, which would mean multiply. So this would be 9 times 10 to the 4th. 2 times 2 is 4. So the next thing I would do, let's worry about the half last, is I'm going to multiply our two numbers in scientific notation. So 2.5 times 9, we're going to multiply that. So 2.5 times 9 is 22.5. And then, because we're multiplying our scientific notation, we're going to add. 5 plus 4 is 9. Okay, now let's deal with the 1/2. Pretty much, you can just take the 1/2 and multiply it times this number. That's the easiest way. So, we're going to divide it by 2. You get 11.25. Times 10 to the 9th. This isn't going to change. We still need to fix this because this is not in the correct form. We're going to need to move this decimal so that it's 1.125 times 10 to the, well, that would make it 10 to the 10th. And there is our answer, and this represents the kinetic energy of this plane in a unit called joules.